occupied France, August 1943. On a remote Luftwaffe airfield just after 0400 hours, Oberleutnant Werner Schultz, Chief Technical Officer of Jagdgeschwader 26, received a piece of news that should have been a triumph. An American P-47 Thunderbolt had been forced down, its pilot captured, and the aircraft itself was remarkably intact. This was intelligence gold. For months, German pilots had been encountering this massive American fighter, reporting capabilities that seemed impossible. Incredible durability, devastating high-altitude performance, and crushing firepower. Now, German engineers would finally have a chance to examine the machine up close, to pull back the curtain on the technology that was beginning to terrorize the skies over the Reich. When Schultz saw the P-47 on the tarmac, his initial visceral reaction mirrored that of every German pilot. It was grotesque, an obscenely fat and ungainly flying milk bottle. The fuselage was massive, built around an enormous radial engine, giving the fighter a bulky, almost clumsy appearance. At nearly 8 tons fully loaded, it dwarfed Germany's frontline fighter, the Focke-Wulf FW-190, which weighed barely 4 tons. It looked, Schultz conceded, like it had no business being in the air. Yet Schultz was not a romantic combat pilot. He was an aeronautical engineer who had worked for Messerschmitt before the war. He didn't care what the aircraft looked like. He cared what the numbers said it could do. And as he began his methodical, cold examination of the enemy machine, the engineer who believed in empirical proof was about to uncover a devastating truth. The P-47 wasn't just a better fighter. It was a mathematical proof, a prophecy whose components demonstrated that Germany had already lost an industrial war its leaders didn't even know they were fighting. Schultz started with the heart of the machine, the Pratt & Whitney R2800 double Wasp engine. When his team removed the cowling, they stood in silence for a long moment. The engine was an 18-cylinder Colossus arranged in 2 rows, a radial configuration that necessitated the P-47's bulky airframe. But the shock wasn't the size alone. It was the quality, the precision, the sheer engineering sophistication. Every visible component was machined to tolerances that German factories were increasingly struggling to maintain. The cylinders were uniform, perfectly balanced, and the crankshaft was a masterpiece of metallurgy, showing no evidence of resource saving or simplified wartime manufacturing. Schultz immediately pulled out his notebook and began calculating. Based on displacement and design, this engine was producing at least 2,000 horsepower, possibly more with the integrated turbo supercharger system. For comparison, the best German engine available, the BMW 801, produced about 1,700 horsepower at maximum output, and that was pushing German technology to its absolute limits. The Americans were mass-producing engines with a 20 to 30% power advantage, and they appeared to be doing it with casual ease, using materials Germany could no longer spare. The problem, Schultz quickly realized, was not just the power, but the philosophy of its construction. His team searched the engine for signs of material shortage or manufacturing shortcuts, the low-grade alloys and simplified assemblies that were becoming commonplace in the Luftwaffe's own production. They found none. This engine was built with high-grade aluminum alloys and precision bearings, the right way, not the expedient way. An assistant pointed out a crucial detail. Each cylinder was individually removable. If one was damaged, it could be replaced without disassembling the entire engine. Schultz nodded, recognizing the brilliance of a design built not just for performance, but for unparalleled maintenance efficiency. German engines required extensive disassembly for major repairs. This American design was predicated on the assumption that downtime must be minimal, a reflection of a vast operational tempo they could sustain. But the true secret, the detail that made Schultz's stomach clench with cold dread, was the turbo supercharger system. Intelligence reports had mentioned it, but seeing the complex network of ducting snaking from the engine down through the entire fuselage to a turbine mounted in the rear was sobering. The system used hot exhaust gases to spin a compressor at over 20,000 RPM, force-feeding pressurized air back into the engine. The engineering challenge was staggering. Channeling superheated exhaust, designing bearings that wouldn't disintegrate at extreme speeds, and precisely calibrating the system for reliability. German engineers had experimented with this technology and failed to field a production model. The material and manufacturing challenges were simply too great. Yet here it was, in a production model American fighter, one of hundreds rolling off the line. Schultz quickly ran the implications. With this system, the P-47 could maintain full power at altitudes over 25,000 feet, the very thin air realm where the FW-190 and BF-109 lost significant performance. The American fighter would be hitting its stride in the high-altitude arena where German fighters had to operate to intercept the bomber streams. When his assistant asked if the Luftwaffe could replicate the system, Schultz shook his head. "Not with our current manufacturing capacity," he stated grimly. "This requires precision machining, high-grade steel alloys, and thousands of skilled man-hours. We are already struggling to produce basic aircraft. Adding this level of complexity is simply beyond our capabilities." The examination of the airframe provided the second crushing realization. The P-47 was a tank. The captured aircraft had absorbed significant battle damage. Cannon shells had torn through the fuselage and machine gun fire had riddled the wings, yet the aircraft had remained structurally sound enough for a controlled landing. Schultz noted the heavy-gauge aluminum skin, the robust internal framing, and redundant control systems. While German fighters were optimized for agility and weight savings, the P-47 was designed explicitly for durability and to absorb punishment. Its extensive cockpit armor and thick armored glass windscreen confirmed this philosophy. Crucially, the R-2800 radial engine itself served as a massive shield. Unlike the vulnerable, liquid-cooled inline engines of German fighters, the radial had no exposed coolant system. Schultz had reports of P-47s returning to base with multiple cylinders destroyed and still running. German fighters with similar damage would have immediately fallen from the sky. The design philosophy was starkly different. Germany built aircraft at the edge of possibility, squeezing performance from limited resources. America built aircraft with massive safety margins, compensating for any perceived inefficiencies with sheer brute force, and that approach was proving superior in the unforgiving environment of combat attrition. The P-47's armament sealed the technical assessment: 8 Browning M2 50-caliber machine guns, 4 in each wing, carrying a total ammunition load of 3,200 rounds. Schultz calculated the firepower, a combined rate of fire of over 100 heavy slugs per second. A typical 2-second burst, common in a firing pass, would launch 200 high-velocity, armor-piercing projectiles into the target. This was a wall of lead. German fighters, with their lightweight construction and limited cannon ammunition, a BF-109 might only carry 60 cannon rounds, would simply disintegrate under this concentrated, sustained fire. The P-47 pilot didn't need delicate precision. He only needed to get the target generally in front of him and pull the trigger. Schultz's urgent technical recommendation was already clear. Avoid head-on engagements with P-47. Probability of surviving return fire minimal. As Schultz compiled his report, the pattern transcended the individual components. Every system on the P-47 spoke to an underlying industrial capacity that was staggering. The complexity of the turbo supercharger, the reliance on high-grade alloys, the sheer volume of aluminum used in the heavy airframe, any one of these would strain German industry. Yet the P-47 had all of them, fully integrated, and was being mass-produced. Schultz requested intelligence production data, and the numbers he received were soul-crushing. Republic Aviation was building P-47s at over 500 aircraft per month by late 1943, with plans to ramp up to 700 or 800. German factories were struggling to produce 300 to 400 single-engine fighters total across all types. Moreover, the R-2800 engine wasn't exclusive to the P-47. It powered multiple American aircraft. Total production of this single advanced engine type would exceed 125,000 units during the war. Germany's entire production of all aircraft engines across the entire war would be roughly 250,000 units, most of them significantly less powerful. The Americans were building more of one advanced engine than Germany could produce total engines. Schultz sat staring at the figures, the cold, hard mathematics of production that rendered all tactical genius irrelevant. American aircraft production for 1943 was projected to exceed 85,000 aircraft, compared to Germany's approximately 25,000, a ratio of more than 3.1. But because American aircraft were on average larger and more complex, a B-17 bomber required more resources than 3 Bf-109s, the material disparity was even more overwhelming. America was simultaneously fighting a global war, supplying the Soviets, equipping the British, and still burying Germany under an avalanche of steel and aluminum. Schultz's final report was not a technical critique, it was a strategic death sentence. His summary read, "The P-47 Thunderbolt represents a level of industrial and technological sophistication that exceeds Germany's current capabilities. Its widespread deployment suggests American production capacity far exceeds previous intelligence estimates." Conclusion: continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses. In plain terms, the war in the air, and therefore the entire war, was lost. His commanding officer recognized the danger of the truth, but Schultz refused to alter the findings. He expected resistance, but the official response was even more chilling. The report was dismissed by High Command as overly pessimistic, and the work of an engineer demoralized by enemy propaganda. The Nazi leadership rejected intelligence that contradicted its ideology, a fundamental flaw in the system. For Schultz, the examination of the P-47 was a personal revelation. He was an engineer, he believed in physical reality. And the physical reality was that Germany was being defeated not by a single act of heroism, but by the relentless, overwhelming production figures of a superior industrial society. In the months that followed, Schultz watched his predictions unfold. P-47 numbers swelled, German fighter losses mounted, and air superiority shifted decisively. When post-war figures were declassified, Schultz's estimates proved conservative. The U.S. produced over 300,000 aircraft during the war, over 15,600 P-47s alone, more than Germany produced Bf-109s and FW-190s combined. The 125,000 R-2800 engines he admired were built not just by Pratt & Whitney, but by Ford and Chevrolet, automotive giants seamlessly retooled for war production. Interrogated after the war, Schultz was asked if he truly concluded from examining one aircraft that Germany would lose. "I concluded that Germany could not win an industrial war against America," he stated. "The P-47 was evidence of a production capacity we couldn't match. Every component, every system, required resources and manufacturing capability that exceeded Germany's total capacity." The American officer showed him his captured 1943 report, stamped, "Filed, no action required." Schultz laughed bitterly. "I expected it," he said. "The Nazi leadership didn't want intelligence, they wanted validation. When reality contradicted ideology, reality was dismissed." The story of Werner Schultz and the captured Thunderbolt became a perfect microcosm of Germany's strategic collapse. A truth seen by competent men, accurately documented, and fatally ignored by a regime that believed we could overcome mathematics.